So after the last set of tests, I was pretty happy. I mean, at the basics, 150 bucks. You know, slightly under that actually. You had a unit that could basically run 100 watts for a pretty long time for any kind of testing. 200 watts, fairly long time. You could just about tune up a 700, 800 watt amplifier into it without a problem, provided you tuned up fast enough. But as I said to you before, that was only the start of what I wanted to do. But that could be, you know, what you want, and then that would be it. And you could do other things, which I'll even talk about later, with it, for just a simple 100 watt rig to test it, to have on the workbench, etc. So I went and went to the next stage with this and did the upgrades. And I'll post in some pictures here while I show you this. But let me lift off the cover and you'll see that things have changed quite a bit. Okay. Well, as you can see, the first thing that comes to light is that I put the hybrid modules on nice, beefy, half-inch here aluminum copper sections, and that's they're bolted on there, and this is bolted onto the aluminum heat sinks. Both sides I have the fan, and the fans here are for, of course, removing heat out of the structure. I have this set up so that it'll pull heat out and keep inside this middle section cool, and take the heat out and blow it out this way, out this side. So in here, where any electronics I have are going to be are in a cool state. I made these from a computer case, and as you can see, I bent them. First cut them from one of those old ATX computer cases. Don't use those new ones. The steel is just too thin on them. This is one of those old 1990 vintage ones. Cut it, bent it, molded it into the shape, bent the edges down here, and bolted it down. It's getting a bit heavy. Bolted it down to the bottom at several points to hold it. I cut out the holes for the fans. Air is blowing in, so you know, it doesn't do much for keeping the hybrid modules cool, but it does do a lot for keeping in here in the center section cool. And the copper I lucked into. Went to a store, a metal machine shop, and started explaining to the guy, and he said to me, "Oh, I think I have what you want." And he took out this huge, about 50 pounds worth of copper, and he said, "I can cut off for 30 bucks a little sliver." He cut it. I still have this, two pieces like this left over from either end. I cut this afterwards because it was too long for my needs here. Yeah, I know some people are going to say it's a huge waste, a lot of more cooling. But gonna run some more tests, and you'll see what the difference the copper made. So that's to keep you up to date. So basically, if you're noticing a couple things, I left small gaps here, going all the way around. It's a gap here, so air can flow all the way out. The vents are set up. That was one of the things I marked out, that the vent holes line up exactly, that the air is pulled in through the lower set of vents here and holes on the bottom, and pushed out through the vents over here. So that basically keeps everything, the power supply, everything inside here cool. And we'll run some more tests and see what happens. And I got to point out, during the process of doing this, I damaged one of the hybrid modules and had to replace it. So and that was a little more expensive. But this basically added on, you know, this was free. I mean, banged out the steel and then shaped it and painted it, sanded it, painted it, whatever, dremeled out the holes here for the fan, bolted on. These fans, they weren't overly expensive, as you can imagine. The power supply wasn't overly expensive. This is a 12 volt power supply. I'd say overall it added about 80, 90, I don't know, dollars to the cost of the whole system. And most of that expense was the copper heat sinks and one trip I had to make down to the machine shop because I didn't want to drill one set of the holes myself. I drilled the other holes myself, but the rest I let them do down there. So we'll run some tests and see how these new upgrades work. It's all hooked up now, and I'm on 20 meters FM. I'm just going to try a straight connection here, seeing what it does. Straight, no amplifier, just putting out near 100 watts, 90 something watts, and see the temperature, if there's any temperature change on the heatsink. I am actually touching the hybrid module, the outer casing, on the metal side, so I'm getting as close to the junction temperature as possible, and I put some thermal compound on the end of the probe. So here goes. I'll start keying now, and a beautiful 1.03 SWR, 91 watts, temperature going up a bit. And we'll just see where that goes. That's been about a minute. Okay, this has been about 3 minutes. I cut there just to save some time, and it's just barely creeping at this point. So I'd say 35, I don't know, a little over 35 is going to be about as hot as it probably is going to get. I don't know, but I don't want to keep my radio keyed any longer than this at 92 watts. So that'll conclude that test. Checking the SWR on it. Let's start here. I'll go down to 160 meters. Put it in FM. SWR is 1.00, 99.8 watts. I've disconnected the thermal probe, so don't pay attention to the temperature dropping. I'm no longer holding it. 80 meters, 1.03, hold on. Oops, put in FM, 1.01. Okay, it's 80. 40, 1.02. I'll skip 10, pointless. Go to 20 meters, 1.03. Put an FM, 1.03 on 17. 15 meters, 1.03. 12 meters, 1.03. 28, 1.05. And 6 meters. Sorry, it was 10 meters before. So on 6 meters, 1.16. So that's really good SWR across. Go back down to 20, 1.02. That's 40, 80, and 160. So the SWR is great. That actually replacing that module actually brought it down a tad. So I'm happy with that. Now I'm just going to do one final check, which will be to see what happens pushing it, loading it with the amplifier up to about 700 watts and 750 watts, and see how long it takes before the buzzer goes off. Well, I haven't tested the buzzer since I put it in, and also to check the temperature, how long it takes to reach up to that magical close to 100 degree, 95 degree. That buzzer, as I told you, is rated for 95 degrees Celsius. The thermal switch is at 95 degrees Celsius. It's supposed to trip and close, and that should turn on the buzzer. So let me try that now. I'm going to switch on the amplifier. Going to put it on 20 meters. $796. So let me lower that down a tad. 815. I don't want. Okay, roughly there. So that's all set, and let's make a test. I've given the heat sinks a little bit of time to cool, a couple minutes. The really nice thing about the copper is that it works both ways. When you're not keying up and there's no power applied, the copper sucks back the heat from the aluminum heat sinks, and the fan cools the copper off, so you actually get a much quicker recovery time than you did before. So anyway, without much ado, let me get this thermal probe on, and you can see it's starting off at 28. Now, last time we did this test, before I put on the copper and the fans, we got 15 seconds roughly before it thermal overloaded. Well, not thermal overloaded, but I think it got near 90 degrees. I'm going to go for, it would have in another 2 seconds been up to 95. I'm going to go up to about 95, 100, just to make sure that the buzzer goes off and everything is working all right with that. So here goes, and see what happens. 730 watts roughly. And as you can see, the temperature is going up a lot slower than before. And we've reached about, let's say 15 seconds already, so we've surpassed that marker. Now reached about 30 seconds. And as you can see, it's just ever so slowly climbing up. And if you needed more than 750 watts to tune an amplifier, you'd be crazy anyway tuning it that high. Great for peak measurements. We've gone to the 1 minute marker. And as you can see, 73 degrees and climbing. About a minute and a half. So we're getting kind of like the performance we got when we had 200 watts before. Even better, actually. And we have reached 2.5 minutes. I can feel the heat coming off of the heat sinks now near my hand. And I'm going to get ready in case I have to shut down quickly. Yeah, the copper is quite hot. My hand just brushed it. And expect that buzzer to go off soon. And we've reached over 3 minutes. And I would have expected that buzzer to go off. And I'm going to cut it now, and I don't know why the buzzer hasn't gone off. And the amplifier has gone into high speed mode. So right now I'm measuring the temperature right on the junction of the thermal switch. I'm going to tune again. Temperature should shoot up rather quickly. And I'm going to go back and forth. And yeah, that's on the hybrid. And this is on switch, and you can see the problem right there. The hybrid again. 105. And I have them so close together, and yet should at 95. And I'm pretty hot there on, and I still, no, and it's still not going off. Well, the good news is that, as you can see, at 750 watts roughly, you've got 3-4 minutes here. This thing will keep running. 3.5 minutes it'll handle that kind of power, which would definitely mean that at full legal limit, you've got a minute or at least a minute of time to do anything you'd want to do, check the power output, whatever, peak it, tweak it. So I'm happy with that. As to why the thermal switch is not going off, I'm going to have to investigate that. I'm probably going to have to pull that off, but that's a simple thing. That really doesn't perturb me at all. It was a straight wiring in. It should have just clicked right on through. It went basically from the plus side of the 12 volts into the switch, and then over and out straight to a 12 volt buzzer. So I can't even see why that would fail. I have, as you can see, it was mounted with about 4, 5, 10, I don't know, 5 millimeters across from the hybrid module, but you can see there's about a 7-8 degree difference in temperature between the hybrid module and the junction point on the switch. So that doesn't really bother me too much, because, as I said, these hybrid modules are derate at 150. You shouldn't really run them much past 100, which give or take, how often will you go a little over before that buzzer might go off. But that all depends. I'm not sure exactly what's going on, so I'll take a look at that and see what that problem is. And for the last test, I'm going to hook up and try the dummy load on VHF and UHF. And I have my FT7900, which is pretty much the bane of my shack. God. Let me just put it this way. I find the Waxon handheld easier to program and use than the FT7900. And let me just leave it at that. Anybody who's used the Waxon will know exactly what I'm talking about. The guys from the I don't even know what they were thinking with the menu system on this radio, but anyway, so it's connected over here, powered over, and boom, into the dummy load. And yeah, you can see the thermal paste I need to clean off that came through the screws, and back over. So let's see how the SWR is. I mean, this is not as accurate a meter, but we should get some clue as to what's going on and how well it's working from that. So it's just prepping for the test. That it's so funny. I key up the unit on 70 centimeters, and I noticed the fan on the dummy load goes dead. Really strange. That's the switching power supply. Evidently, some RF is getting in there and killing it. You unkey and it comes back on. So I just unplugged that for right now. Not something I'm worrying about. I don't even really have any plans for using the dummy load much on 70 centimeters or even 2 meters that much, but it's just interesting. There's more shielding going in anyway, but so that problem will go. But something to note for people who build their own. That's a problem. The other thing I noticed is the display on this 7900 is actually orange, and it's showing up on the camera viewfinder as like green, really a light green or yellow. Strange, very strange. But anyway, let's go with this and see what happens. So we'll start off calibration. I don't need the fan, so I've disconnected the fan on the dummy load, because this is not going to have much power at all anyway. Leave it on 200 watt range, and the power setting here is set to low, 145 megahertz. Key up, calibrate. This thing is so touchy. Good enough. Alright, power output. So it's about 4 watts, and the SWR, look at that, that's like 1.15, I don't know, 1.2 at max. Let's increase the power. Just go for the high. Okay, put that in 200 watt range, calibrate. And yep, looking good. And key up. We got almost 50 watts out of that. What's the SWR? The SWR is, whoa, about 1.4. 1.4. So a little increase as we go up in power. That'd probably be the true SWR. About 1.4. So I'm really happy. 2 meters, dummy load works fine. No problems. 50 watts into it. So let's go up, and we'll go up into the 70 centimeter range. I'm thinking about a frequency here. Let's just try 445. Okay. Power is still set to high. It's key to calibrate. Good. Power output about 30 watts. 30 watts. That's on the middle scale here, and that's 50 there at that marker, so it's 30 watts. And let's see what the SWR is. Fingers crossed. Whoa. SWR is really low, 1.1, a little over 1.1 on the SWR. So that is fantastic. So these hybrid modules have no problems doing 70 centimeters, and you know, within normal power ranges that you'd find in most VHF, UHF rigs. I have no idea what would happen when you put a couple hundred watts on there, but I don't have an amplifier in that range. So that's nice. I'm happy with that. So far this really is going anywhere from 160 meters to 70 centimeters, no problems with SWR. Extremely low SWR. The most, as I said, is on 2 meters, and that was 1.4. Most everything else is either 1.0 or 1.1, somewhere in that region. Anyway, happy with that. So as you can see, with those last tests, the copper works great. These Knock 2 fans that I put in, they work good. That little glitch there with the switching power supply, no problem. The beep, I'm just gonna change the thermal switch. I don't think I have the right value there, but that's nothing big. Everything seems to be alright. Yeah, my little buzzer here, still here. But everything seems to be good. So, as I said, very happy. This is stage 2 of it. And as you can see, I have the 2 connectors here, 2 PL259 connectors, and I'm only using one. So, you could use, theoretically, you could build a circuit board, put back here, put a switch, and bypass through, and use it as a dummy load that you can bypass through to an antenna if you want to. Or you can go another route. As I said, I am not happy with just having this big blank screen. And I've already started working on some things, a couple connectors there, as you can see, for testing, a switch, and I've started some programming, and an Arduino, and a DDS chip. And yes, it's it's working, and can do some tests. Forgive that 141 at the end. Put my finger on the temperature probe here. Take my finger off. And that's supposed to say 1000 watts at the top there. That's just a preliminary amount I set in there. The 51000, that's a bug in the program that I'm still working on. But yeah, it's basically, you can see that there are things you can do here, and this board fits in perfectly right on the front here, and leaves spots for the jack and the power switch here. So, you know, it's up to you where you want to carry something like this. I have some ideas. As I said, I have some heavy duty relays that can pass 3000 watts of power if need be. I only need them for you know, say 1500. But if I wanted to, I could just have this as a nice bench desktop dummy load at my shack, just to do quick checks and switch over to the antenna if need be. Or as I'm planning to use it on my workbench, I could go in the opposite direction and do analysis on what's happening. So that's pretty much it for right now, for I guess this segment of it. And I'll put a future video as I update this and finish the software and cut up the front and get everything else in. It's going to be quite tightly packed, but you know, the RF is certainly going to be just an issue I'm dealing with as I go along. But thanks a lot for watching, and stay tuned for more on this soon. Have one or two other projects I have to finish first before I go back to this. But I've actually been using this dummy load for a few things I'm working on right now, and it's worked great. And yeah, those fans are just so quiet. You can go right up to them and they're just so quiet. So anyway, catch you later, 73s. Yeah, just a quick little add-on. I just thought I'd show you here. There's some air being pulled from the bottom, and at the top here you can see it sucks the paper right down here. And as you pass this point and get to where the outflow is, you can see the paper is lifting, and that's the air blowing it across. And if I bring it back, paper gets sucked right down. As a matter of fact, it's now being held kind of rigidly. So there's a nice cool airflow in there. It's pulled in from this section on both sides and out here, and air being pulled from underneath. Switching power supply right here is kept cool, air pulled in, air come out. So anyway, the inside, the internals should be nice and cool, and that's what you're looking for when you're going to put other circuitry in there, that and getting rid of RF. Anyway, just thought I'd add that, and if you want to subscribe, because if you don't subscribe, then you won't know when I post the next section with this, and you won't see the other couple repair videos I have that are coming out that they're actually finished. Just need to edit them and get them out. So take care, guys. 73s.